So in this video, we're going to look at the analog output option. Basically, so far we have shown you what the value of the width measurement is on the display. We do have the ability to output that value in different forms, and one of the common way of outputting the value is through an analog output. Even though we prefer to provide a digital output, the analog output option is available so that you can connect to a legacy system where you have just a way of logging the data into your PLC if your PLC is old and it doesn't have the Ethernet communication option. Let's go over that details again. So in the last video, we had this set up as width measurement as the output option and with the error as the option. So we're going to first go back and change that to absolute. So this is the actual measurement, so it's going to show you the actual measurement there. And in terms of the different analog output options that we have, we can go in here and go to power user analog, and you can see the different output options we have. We can provide a voltage output 0 to 5, 0 to 10, plus or minus 5 or plus or minus 10, or a current output that is shown here. We're going to start off with the voltage output, and right now it's set to 0 to 10 voltage, and we do have an oscilloscope connected, and that is actually showing you the actual output from there. On the bottom you can see the different values for that thing, and if we do have a width change, we should be able to see that on the analog output. I'm going to add something there, and you can see that the width changed and it came back again. This particular setup right now is set for 0 to 10 volts. So the maximum width change that you're going to see is 10 volts. To ensure that the analog output from our controllers working properly, we do have an ability to set the full scale and the zero scale value of the analog output. So that'll be a quick way to make sure that the analog is working properly. So you can set it to 0. Now as you can see in the oscilloscope, it goes to 0, and then when you put it to full scale, it's going to go to full scale. Now if you had a different full scale value, that is 5 volts, and you can see that 0 and the full scale value changes as well. And then once you're ready for normal operation, we can set it to normal, and that's going to provide you the normal operation. So let me go back to 10 volts, and then that's providing you the output. This value 64 millimeters, and there is an analog output corresponding to that 64 millimeters, and that one is approximately 5.1 volt. And the way in which we compute that is, in our case, we are using an 112 millimeter sensor, and the width measurement is 64 millimeters. So you take 64 and divide it by 112 and then multiply it by 10, and that's the voltage output that we get. So if we have a wider sensor, then the voltage output is going to be proportional to the width of the web with respect to the range of the sensor. So if you had a sensor that is double the size, like 221, the output would be 64 divided by 221 times 10, and that's going to be close to about 2.5 volts. That's how the output is scaled. So we do also have the option to do the polarity, and basically what it does is it inverts in our current case right now we're measuring a certain width and it's providing a certain value, and let's say the width is 80 millimeters and then the range is 112 millimeters for the sensor, so it'll be 80 divided by 112 times 10. That's going to be the output. Now if you want to have an inverted value, then you can just set that polarity, and that's going to invert that output, and that output is basically 10 minus 80 divided by 112 times 10. So this is useful for certain applications in which you have certain edge of the web that you are looking at, and you would rather see the output based on whether it's shrinking or expanding. That's what that polarity thing is there for you to set. Apart from looking at the output like an absolute output, like in this case right now the absolute measurement is 83 millimeters, and then the analog output is going to be 80 or 84 divided by 112 times the range. We can also get a relative output. So if we know what the nominal width is for this product, let's say nominal width is 84 and then we set the output type to error, and obviously on the display it shows you the error output, but on the analog we can also get the error output. So the output that we get, analog output that we get when we have an error, is going to be, if it is a positive positive error, then it's going to be whatever the mid-scale value is plus whatever that error is. So in this case the error is 64 micron, so the mid-scale value is 5 volts. So the output would be approximately close to 5 volts. And if we go look at that in the oscilloscope, you can see that the output is pretty close to 5 volts there. Now if I take off one of these and change the width of the web, then you can see that now the error became 19 millimeters, and that's what you're seeing in the oscilloscope as well. The voltage actually went below 5 volts, indicating that we have a negative error. And likewise, if we have the width greater than the actual width, you're going to have a positive width. And then if you go into the oscilloscope, you can also see that now the voltage is about 8 volts. This is the way in which the analog output can be used to either provide an absolute measurement or a relative measurement based on the nominal width setting that we have. It's also true that we can pretty much set this to whatever voltage that we want. So if we do plus or minus 10, now if it is a positive voltage output, then the output would be positive on the oscilloscope. Right now we have a value of about 1.48 volts, and if the width changes, let's say I reduce the width, then you can see that it changed, and now we have a negative voltage, either positive or negative if we do plus or minus 10 volts, and the 0 would be the nominal value. So this can be used for different applications. Let's say a blown film line, you want to change the bubble width, and you can have a blower turn on or off, whether based on a positive or a negative output, based on whether the width is above the nominal width or below the nominal width. Yeah, that's for setting up the width measurement with an analog output. In the following videos, we'll look at how we can do with 2 sensors, and also how we get the digital output from there. Thank you for watching. Please subscribe to our channel for more information about our products and how we can help you. Thanks.